Okay, did you find out what was different? I'm going to give you a little bit more time. I'm going to explain the end of this video. So now let's take a look at this problem here. Okay, so we have the same example, right? The random manufacturing. But in this case, we have a table help us find out the solution. And we're going to use first a method that is kind of more well known in the finance realm, right? So if you think 100% as a finance person and renounce your operations for a little bit, you're going to see that the circular saw have a profit of 900, the table saw has a profit of 600, right? So it makes sense that you will start trying to make as much circular saw as possible because the profit is higher. Okay, so we're going to take a look how does that work with our product mix and see what is the profit of that, right? So you got your the table page 73, sorry. You have a table on a class notes, and I'm going to write on that table. So here it is, page 73 of your notes. Here is a table of our constraints, right? So remember that fabrication X1 took 2 hours there in fabrication and 1 hour at assembly. And of course, if I decided to do X1, it's going to take 1 times X1, and I have the market demand here for X1 and for X2. The same thing for X2. So here I'm going to decide how many I'm going to produce. It's going to take 1 hour off fabrication, 1 hour off assembly, right? And these were basically our equals and equal, right? So this was our constraint, right? So if I'm going to decide, okay, purely financial, I'm going to look at that's $900 off profit. Let's try to make as much X1 as possible. So how many X1s can I produce tops, the maximum amount? That'll be 2,000, right? Because 2,000 is this constraint here, and also the capacity of fabrication, right? It takes 2 hours. If I make 2,000, that's going to be on my capacity of 4,000, right? So if I make 2,000 here, it's going to give me 4,000 plus I cannot make any X2 anymore, right? Because I'm totaling that 4,000 there. So I'm going to make 0 X2, and that's going to give my total of 4,000, right? So no X2s are going to be made. Again, 2,000. X1 is going to give me 2,000. So I'm going to use 2,000 hours in assembly. I have 5,000 hours available. That's not a problem. And 2,000 here will give me the 2,000, which is the total, right? So I'm dealing with this constraint, and I'm kind of capping with this constraint as well. This is going to be 0, right? So maximizing the profit of the one that have the highest profit, I'm obeying to all my constraints. So what is going to be my profit is going to be that 2,000 times 900, which is 1.8 million, right? That's my profit. Okay? Question is that profit optimized? Is that the highest amount that I can make with this situation, right? If I'm looking only in a financial standpoint, I would say yes, it is. But we're operations people, right? And we need to look a little bit further than that to trying to understand what is limiting our ability to produce. Okay, so I just talked through 5 minutes and it was not recording. So let's you guys are not going to see that, but let's first fill this up, right? So with the numbers that we know, 1, 2, 1, 1, 1, 1, and 1, right? So here we're going to put our operations hat here, right? Forgot about your finance hat that we left before. And we're going to take a look at the thing that is restraining our production, which is our bottleneck, right? So we talked about the theory of constraints, and the bottleneck is the one that limits the capacity, right? So which process is limiting our capacity to produce? Well, it is fabrication, right? Fabrication is the one that we're hitting our bottleneck here. So instead of only looking at the profit per unit as we did before, we're going to look at profit per hours at the bottleneck. Well, why is that? Because maybe some products are giving us more margins, more money, but they're taking a lot of hours in our bottleneck. So per hour in the bottleneck, they don't make as much money as other ones. So let's take a look at our fabrication process and circular saw and table saw. So profit per unit, that's going to be 900, right? Divided by 2 equals to $450 per hour in the bottleneck. And then for table saw, is going to be 600 divided by 1. So that is $600 per hour. So look at what is happening. Actually, when we decided to do this one here, we filled the bottleneck with X1s, and it actually produced less per hour, dollars per hour, than if we put the X2. So X2 makes a lot more sense to produce than X1 because of the hours at the bottleneck, and that's our operations hat that we're putting there. You have to think in the bottleneck, in the theory of constraints, what you learn in operations management, okay? So let's do the other way around. Let's try to do X1 first, because it gives me more dollars at the bottleneck, and the bottleneck is what actually constrains how much I can produce. So what is the maximum amount of X2 that I can produce? Well, here it's 1500. It's limiting, and I think this constraint will be okay with 1500, right? So we're going to go with 1500, and that's going to give us the 1500, and that's going to be the total, right? We're going to put the 1500 here and 1500 here as well, right? That's going to give us 1500 and our 1500 here, okay? So we still have 1500 here. We still have some capacity. So what we do with the leftover capacity, then we go to the next product. So after you fill the one that has the highest, you go to the next one, okay? So the next one here will be the X1. How many X1 can I produce? Can I produce the 2000 X1s? No. I have to take a look at what's left over here, right? So I use 1500. The capacity is 4000. So I still have 2500 available, right? Hours. Oops. But I have to divide by 2 because it takes 2 hours here. So give me 1250. So if I have 1250, I'm going to have the amount of 2500 hours plus 1500 hours. That gives me my capacity of 4. So I'm reaching this, and also it gives me more here. So I have 2750 here, right? Adding this 2 and 1250. So still okay. 1250, 1250 here, right? So I'm hitting this, and still have some extra here, right? So the question now is, what's going to be my profit? So going back to the objective function is 1250 times 900 plus the 1500 times 600, and that's 2025. 2,000,000, and 25,000, right? So remember, before we had 1,800,000. So is that to optimize the profit? No, 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 no. Okay. How much profit we increased by doing this? Well, we had this much, now we have this much, so we increase 225, right? To be the 2,025,000 minus 1,800,000, $225,000, right? Not bad, not bad. If you divided this by this, you're going to get about 12.5% increase, right? Which is a huge number. Okay, so that's why you need to use linear programming. That's the powerful of this method, because you can take any decision that have a lot of constraints, a lot of variables, and you are sure that you get the right answer, get the best possible answer, instead of relying on the subjective things and end up not having the best option. Did you guys find out what's new? My chair is new. See, I had a $30 chair that I bought when I got here to US 6 years ago at IKEA, and was really cheap and was really bad. And now I have a beautiful one that came from Amazon, right? So that's the new thing. That's what I'm going to ask you, okay? So good luck with the problem, and see you guys in class.